Hey everyone, Professor Baldwin here. I'm so glad I was asked this question because it looks simple. It's got 4 terms, so it looks like you should just factor by grouping and be done. But no, there are a lot of different parts to this problem. So yes, 4 terms, factor by grouping. But always remember, you have to look for that GCF first. So do we have a GCF? Yes. 2 and 6 are our coefficients, and they have 2 in common. So if we factor out the 2, we would have r cubed plus 3r squared minus r minus 3. Now, that polynomial in the middle, we can factor that out with grouping. So our first 2 terms have an r squared in common. So we factor out r squared and we have r plus 3. And then our last 2 terms. Well, we want to have an r plus 3 factored out. And to do that, we have to factor out a -1. And then don't forget, bring down that GCF of 2. Okay, now that we've done factor by grouping, we can factor out this binomial that they have in common, and that is the r plus 3. So you factor out the r plus 3, and you're left with the binomial r squared minus 1. And again, don't forget that GCF of 2. So you might think, hey, I'm done. But look at this last binomial, r squared minus 1. Remember that 1 is a tricky number because 1 is itself squared. So this is actually the same as r squared minus 1 squared. And seeing it that way, you can tell that this is a difference of squares. So that means we have to factor that last binomial. So we keep our GCF of 2. We can't factor that first binomial, r plus 3. But the last one, r squared minus 1, we factor as a difference of squares, which is r plus 1 times r minus 1. Remember, go slow, always start with the GCF, and once you think you're done factoring, look at each of those terms and make sure you can't factor any further.